In this video, this is the video for Mod 1 Lesson 4, Exponential Functions and their Inverses. The learning targets for this video are going to be to determine the inverse of an exponential function, to determine the domain and range for an exponential function, and to identify asymptotes for an exponential function if needed. For the first example we're going to be looking at just the function y equals 2 to the x. As you remember in Math 2, you guys talked about exponential functions, where exponential functions have x in the exponent. And so characteristics, hopefully you notice here, are that a few different things. We end up having our equation in the form of y equals a times b to the x, which you might remember from Math 2. We do have it where you could see it starts off with lower values and then it gets larger or exponentially larger. That's why we call it exponential function. You can see that it never actually goes below y equals 0. Right? So in this case, it keeps, when you go to the left, it keeps getting cut in half, but never actually gets to a negative number. So it does have what we call a horizontal asymptote. So it's horizontal. We also have a domain and range where the domain is all real numbers. And the range, you can see it never goes below this y equals 0, but it never actually touches it either, right? So we can't actually include that value. So it goes from 0 to infinity. For the table, we can get our values like right off the graph, or if you know, again, it's 2 to the x, you might notice that it has that multiplier of 2, so you can even substitute the values in. So like at 0, you can see it's a 1. At 1, you can see it's a 2, and then a 4, and then an 8. In the reverse direction, it might be hard to see, but if you use that same pattern, it's actually getting cut in half each time, right? So this is actually 1/4 and 1/8. If I wanted to graph the inverse, I can do what I did in the other, what we did in the other sections. We can just simply flip the x and the y. So we have 1/8 and -2, 1/4 and -1, 1 and 0, 2 and 1, 4 and 2, 8 and 3. And then if we plot that, you're going to see again that inverse, it's going to be reflected about the y equals x. So we have here 1, 0. I might plot first. 2, 1. 4, 2. 8, 3. And then if I go in the reverse direction, I would have at 1/4 it was -1, and it would get really, really close to x equals 0. And so you can see it would be reflected about the y equals x. In part D, it says the inverse of 2 of x can be written as log x base 2, right? So that's something you might see come up a little bit. We don't do a whole bunch of logs in this mod. You're going to see that in one of the later modules. But it's challenging to write an inverse when you have x in the exponent. So the inverse of that is actually using what we call a log. So the log is the inverse of log base 2, or base b, is the inverse of b to the x. The domain and range you can see is just the same domain and range we had in the last slide, but it's just flipped around, right? So you could see the domain, it gets really, really close to 0, but it never quite gets there. And it goes to infinity. And then the range, you can see it's going to keep going down on the y value. It's actually all real numbers. The relationship, hopefully you notice, is that really it's the flip of it. So f of x has a domain, so the inverse has the domain we just did. F of x has a domain of really the flip of what we just did. So that's kind of the relationship you're going to see with inverses. The domain and the range just flip. If you have any questions, you can sign up for T-Bolt time, get help from the center, or ask for help during class.